Hello, let's play some dominoes. It's time for pips. Let's start with easy. Let's start solving. All right, what do we have here? The 11 is going to be a 6 and a 5. So how do we arrive at that? We need a 6 or a 5 that's connected to something that could make a 10. So it'll be this 5, 4, and then the 4 will connect to a 6. The other 6 will go in the 11, and then we need a non-equivalence region and a 9. Looks like the 9 is going to have to be 3 3s. So that equals goes there, which means we can't have the 6 equals coming off of the 10, so it'll be 6, 2, and then we'll finish the 11 with a 6, and there we have it. All right, that was the easy puzzle. Let's try medium. Okay, got a big T. We have a 2. That could be a 2, 0 or a 1, 1. And it could even be a single domino, actually. We need 4 zeros. Sorry, okay. So the 2 cannot be 2, 0 because all of our zeros are spoken for. So the 2 will be double 1, and one of those 1s connects to a greater than 4, which can only be a 5. So that goes there. That's fine. Now we don't have any, we do have a double 0. So we have a double 0 which could go here, or we could start it off with a 0, 5 to make the greater than 4. I'm not sure which I think is more likely yet. And we have another, well, not another, but the 0 is effectively an equivalence region. We have a true equivalence region of size 4. And that looks like it'll contain 4s, or maybe it has to be 4s. Okay. Does that tell me anything interesting? Oh, this is real. Oh, I see. This is all about 4s. Greater than 4, greater than 4, greater than 4, 4, greater than 4, and then our equivalence region is 4s. Okay. So let's see. We do have a greater than 4 connected to a 4. So this could go here, but if we did that, we'd need an equivalence here, which would have to be 3s. Let's just try this and see if it works. I'm starting to try and train myself to not be sort of offended by needing to, oh no, this doesn't work. Oh, sorry, sorry. I was confusing this 4 region with one of the things where I need all those 4s. Sorry, the greater than 4 doesn't connect to a 4. It connects to actually something probably less than 4 so that we can make 4 in the region because we've already used all our zeros. Yes, so, sorry, that whole thing was fruitless. Right, so if we use 4 4s for the equivalence region, we have one more smaller equivalence region that obviously can't be 4s because we don't have enough of those. It could be these. It could be this double 3. We've got that, but it could also be 1s or 2s. Oh wait, no, it can't be 1s. It can't be 1s because we need it. We need a 1 up there. Okay. So it could be 2s. Actually, could it be 2s? Well, it could be if we had a 2, 6 here. That's the only way that it would work because we don't have a double 2. Is that fine? And then how do we make this 4? We could make it of 3, 1 or 2, 2. We can't make it of 2, 2 in this situation. So it would have to be 3, 1, which actually also is not possible because our only 3s are here. Okay, good. So this has been disproven. So the equivalence is not double 2, which means, I guess that means the equivalence, I don't think it'll be double 1s. No, it can't be. So I think it is the double 3s. I think it is that. Then we have a greater than 4, which connects to something less than 4. It connects to a 1 or a 2. No, not a 0, because those are all spoken for. So I think it might have to be this 6. And then we need a 2 connected to the 4. Could be connected to this 0. In fact, it needs to be, because we don't have a 2, 4 to connect it to the equivalence region. So it is 2, 0. That's fine. Now, do we have a 0, 4 to connect these? I don't think we do. No, which I think means this needs to go this way. And now we need a double 4 that must go, that must go this way. I think this is all fine so far. Now we need a 0 connected to a greater than 4, which is correct. And we need two more 4s. One of them is connected to a greater than 4, which goes there. We've got our last 4, which goes here. And we can finally put our final 1 in, which goes there. And that took longer than it probably should have, but that's okay. We'll move on to the hard. So let's try it. Okay, we've got... Oh, interesting. Look at this. I think this is fairly rare. Have we had this before? An inequivalence region that has one of every single pip represented. So our only 0 will be inside there. One of our 2s, sorry, one of our 1s, one of our 2s, one of our 3s, one of our 4s, our only 5, and one of our 6s. So 0 and 5. We cannot put a 0 nor a 5 anywhere else in this grid. They must go in here, but that in and of itself doesn't seem like a huge restriction yet, I must admit. Now the 6 connects to something that, you know, as part of two cells, I should say, adds to greater than 6. That also doesn't feel like a huge restriction. Simply adding 2 cells greater than 6 is not difficult. I guess it means we can't put the 6, 0 there, because then we couldn't make this greater than 6. But I think that's really our only true restriction, because even if we put a 1 in there, we could still put another 6 here, and that would be fine. So I don't really think that's telling me much, unfortunately. The 13. All right, is this a case where I just also start trying things? I don't know. There's probably something clever I could be doing here. 13, again, 13 is just not, it's also not very difficult. 13 and 3 cells is an average of, 4 and a third per half, which is not difficult to achieve given how many 6s we have. Yeah, I don't know. I mean, maybe I was going to say maybe the question is where do we squirrel away all our 6s, but that's not hard because we can, we get one of them in that 6. We can actually only get one more in the greater than 6 because we don't have a double 6. So, we could do this and then we could put one more of them up here. So that's a total of 2. We can only have 1 in the non-equivalence region. So that's a total of 3. We could obviously put 1 in this empty space. So that's a total of 4. We could put 1 in greater than 2. That's a total of 5. Yeah, I mean, that's not difficult at all. Okay. That's not, yeah. It seems neither difficult to contain them all nor to find ways to use them all. Neither of those feels particularly challenging. All right, I'm just not really sure what to look at here. So, okay, it must be this thing with the non-equivalence region. A 0 must go, our only 0, I should say, must go in it, and our only 5 must go in it. Is there some reason why this sort of 5 and why the 3, this can't be the 3 that goes in there? Maybe all right, I'm just going to have to start trying things. The problem is I don't even know where to begin. I guess with the most constrained thing I can currently see, which is putting a 6-1 here, which necessitates putting another 6 up there. That is not very constraining, but it means now we only have 1-1 to put down here. And it means we need another 6 up top. Can't be the 6-0, so it's the 6-4 or the 6-2. I don't know. Again, I just don't get, I'll just put the 6-4, I guess, for now. It doesn't seem difficult to achieve. So now, although, now down there, we only have 1 4 option, 1 1 option, and 1 0 option. It's kind of interesting, I guess, but I just don't really see how this is difficult to achieve. 0, 1, 2, 3, 5. We can still make 13 this way and greater than 2 here. No, I've done something wrong, sorry. 6 greater than 6. 0, 1, oh, sorry, I've doubled up. 0, 1, 2, 3. I don't have a 4 in there. Okay, that was wrong. I mean, yeah, I mean, this isn't going to work, but I was just kind of randomly putting things in. There's got to be a better way to do this. There really has to be. I just don't know what I'm meant to be thinking about at all. I mean, you know, things start feeling constrained once you actually start putting things in, but I don't know how to think about them until that point. And this is already not working. I guess one thing I could figure out, this 0, you know, does this need to go this way maybe? I don't know. 0, 1, 2. No, this is broken actually. Because now we need to get a 4 in there. Oh, no. We don't have a 6 in here yet. 0, 1, 2, 3, 4, 5, 6. Oh, this works. Does it? Yeah, it does. I don't know. I don't get it. I don't get this one at all. This I have maybe the least kind of understanding of what I could have been doing to make this work. Usually when I say that, someone comes into the comments and has at least something that I missed. So hopefully that happens today. Yeah, I just don't know. I don't know what I should have been looking at here. Let's see. I don't think it was hard to make the 13 in theory. This greater than 2, you know, you can place this in such a way where it doesn't even need to interact with the 13. This inequivalence was interesting to consider, but I don't know what limited me up at top. I don't know. All right, those were the pips. Back tomorrow. Bye for now.